where they intersect. They intersect at this point 1, -1. It's the overlap of the two lines. And then when we did inequalities on number lines, if you think about the and inequalities, we would graph the first one and we would graph the second one, and the overlap again is where we would find the solution. We're going to be talking about overlap. So we're looking for overlap. That is the first blank you can fill in. Okay? So one thing you can do here, every time that you come to these inequalities, you can pause the video and graph them. Okay? That will help make things go a little bit faster. So we graph each line. Okay? And just as to remember that this means dashed line. So if you have a less than or a greater than, those are dashed. The less than means below. So both less than and less than or equal to are going to shade below, and both the greater than and the greater than or equal to are going to be above. So we graph each of the lines. So there's my 3x plus 3. It's dashed. And then when I'm doing this with pencil, I shade like this right here. Where on the computer you're going to see a full shading. But if you make your arrows going down for below and up for above, then you'll be able to tell when they overlap. So the second one is a solid line, including the line. And then we're going to shade above from there. So if I'm doing this with a pencil, I shade like that, or shade straight up from the line. And then the place where you see the overlap is where we're going with that. Okay, so you can see the overlap, and you always want to do this lightly because you're going to need to erase. Your final answer should just be that purple part right there. And then there's infinite solutions. All of the stuff out there in the purple area is infinite solutions. So since there are infinite solutions, all we got to do is look at if the point in that area. So is 2, 5 in that area? Yes, it is. So it's a solution. Is -3, -1? No, not a solution. 0, -2. Now it's on the line. If it's on a solid line, it's a solution. If it's on a dashed line, it is not a solution. If it's on -1 would not, 0, -1, -1, 0 would not be because it's on the dashed line. 1, 1 would be in that region. Okay, so pause the video, and these are just slope-intercept form lines. You can graph them, and then I'll talk about them. Okay, so there's -1/3 x plus 2. Remember, negative slope, and we're going to be shading above, and then greater than x minus 2, shading above. Again, where did we overlap? These were two greater thans. There's really 4 places you could have this as an answer, this, or that. One of those 4 answers. We want the place where they both are at. So it's that top space. And 2, 2 would be a solution. Y is greater or less than or equal to 2/3 x minus 1. So I'm going to shade under it. And dashed because it's no equal to, and I'm going to shade above it. And again, there's 4 places where your answer could be. 1, 2, 3, 4. This is the spot where they overlap. So you darken that in, erase the other stuff. Don't take forever coloring. This is not a coloring activity. So I'm going to make this kind of fast here. One thing you notice here, both of these are very similar, x minus 2y, and it's going to end up with a parallel line. That's what we knew from before with graphing lines. A couple things here. When you need to solve for y to graph this, put a 1 in front of the x. A lot of people are forgetting that 1 needs to stay there because then they're changing. When they divide everything by -2, they're changing this to a 2, and it really should be a 1/2. Okay, so I have y 1/2 x minus 2. Now, we divided by a negative, so that means the inequality changes. Okay, and so the other one's going to be basically the exact same thing, except over here you had a -4, so it's going to be +2. So we're going to have parallel lines. They're both going to have a slope of a half. There's the first one, shade above. There's the second one, shade below. So the overlap is the middle part. Okay, so with two lines, you can have, again, multiple solutions. You could have the part below, you could have the part above, you could have the part at the very bottom, you could have no solution. This would be outside of our shaded area. Okay, here's a little thing to help you keep the thing straight. It's on your notes, help keep the sign straight. If you put your finger on the sign and look to the left, that says above and solid. Put your finger here, solid below. It's kind of just a little graphic organizer to help you. Put right here, this is above and dashed, and this is dashed below. So anything over here, any of the less thans are below, greater thans are above. You really need to know the names of. Okay, so I'm going to graph, these two lines are graphed on here, right? Both have a slope of 1. We're going to shade below the x minus 2 and above the x plus 1. So if our answer is our overlap, there is no overlap. That's the situation where you have no solution. So you won't ever write infinite solutions because every one of these has infinite. So there's parallel below, below again. This time the overlap is this area down here. So that is also a possibility. So when you have parallel lines, you could have the stuff between, you could have the stuff below one of the lines, you could have the stuff above one of the lines, or you could have no solution. There's still 4 cases. Okay. So pause it, and I want you to graph both of these, and then we'll check it. Okay, so I'm going to graph this first line. That's just a horizontal line, right? And we're shading below. That follows our rules. The second one, though, you need to solve for y. Again, give yourself some space over on the side of your paper. This is -1y greater than or equal to -2x plus 3. Divide everything by -1. That gives you 2x minus 3. Overlapping area out here in the corner. Looking at this one, they're going to be parallel. So you're going to figure out, are they parallel in between sharing? Oh, those don't have any common area, so that would be no solution. We play this one. You are not here. Just show you some of the answers. You can pause and get extra practice, especially on like 5. You need to solve for y. 6. So pause it, work it out if it helps you need extra work. So we are at the second part of our project, and so you're going to be graphing 3 inequalities. So to do that, we practice with a cool down, and so we need to solve all 3 of these inequalities. So I'm going to put a 1 there because I see the mistakes when people don't. So -1x minus 9. The other thing is that start writing the x in front. You need it to be in front, so you might as well just get used to doing that. We're dividing by a negative, so this becomes 1/3 x plus 3. So it's a solid line, and we're shading below. So up 1 over 3. I can't do very good lines on here, but I'm doing my best. There we go. So we're shading below. That's all the shading you need. You don't need a whole bunch. You don't need to color it in. Right here, solving for y. -5/3 x minus 3. Okay, so we'll do that one. Down 1, 2, 3, 4, 5. 1, 2, 3. It's dotted or dashed, and I'm shading above. My line's going up. So right now I know my answer's got to be out here in this area so far. But the last one is a vertical line. So the vertical line, I just make it. Try to make that purple. It's at x equals 3. And I'm shading everything to the left. Now, at this point, you can see I already have overlap in here. So my answer is going to be the place where all three things overlap. So it's going to be this area inside of this triangle. And this is what your project's going to be. You're going to make it's called a feasible region. You're going to make that your own feasible region. Okay, that's it.